Hello and welcome to Fusion 360. This is Mr. Hernandez, and today I'm going to be teaching you how to do what you're seeing on the screen here. I modeled a beam and then I applied a force to it, and then I could measure the deflection and the stresses within that beam. And we're doing that for this project so we can compare different cross sections or different shapes from the side. So this is like a square tube, whereas this is kind of like a C-shaped beam or a C-channel. And we can see that this one kind of failed by twisting, whereas this one just went straight down. So we are going to be doing this so we can compare different cross sections and see if we can't determine what's strongest, and see if we can't learn from this and figure out what might be best for us when designing our bridges for the next project. So the end goal is to get to something that looks like this, but I'm going to show you how to do that from square one. So I'm going to open another page here. When you open Fusion 360, it's going to look like this. Nothing's going to be showing on the screen yet. In order to access this software, though, you do need an educational account. So please do go to autodesk.com and create a free account so that you can use the software. When you open the software on the school computers, it will ask you to log in, but then you're going to be able to use it just like I am. So I'm going to assume you've already done that. So here we go. Now, the first thing you're going to want to do is click on your name in the top right corner. So here I am, Tyler Hernandez. Select Preferences. And there's two things you want to change here. You want to go to Unit and Value Display and make sure this is showing in English. I think it shows metric standard first. So we're going to show English. And then we're also going to go down to Default Units, and under Design, we're going to select inches, and then under simulation, we also want to select English here as well. So we'll hit apply and OK. So that'll change all of our measurements to English. But if we start drawing right now, it'll still show in millimeters or show in metric, because that's the default. In order to change that, if you go to your document settings here and select units, it'll show inches. So now we should be showing in inches. So okay, here we go. Now I want to draw my beam so I can make it, so I can test it. And the best way to go about doing that is to first draw the cross section, and then we can kind of stretch that out and turn our shape into a beam. So in order to do that, we need to make a sketch of the cross section. So I'm going to go over here to create sketch, and then this is going to show this weird thing here, but all it's doing is asking you to select a plane that you're going to be working in. We're designing in 3 dimensions, so we're just selecting one of those dimensions to be our working dimension. So I'm going to select this one here, and you can actually select whatever dimension you'd like. It will not make a difference. Okay, so here we are. I'm going to zoom in a bit. We know the sticks we're using are about 1 inch long, or 1 inch wide, I'm sorry. They're 1/8 of an inch thick, and they're 18 inches long. So we want to be drawing kind of like on this 1 to 1.5 inch scale. In this case, I don't want to be drawing the same beam as any of you guys, because I don't want you to be able to copy the steps that I'm doing. I want you to have to do some thought, but I'm going to show you all of the skills that you need. So I'm actually going to make a T-shaped beam. And in order to do that, I need to draw a T-shaped cross-section. My name is Tyler, so I'm going to make a capital T here. And I'm going to start with this line tool. So if you go to the top left and click line, now whenever we click and drag, we'll start drawing lines on the screen. I can draw whatever I want. And that's my shape. However, that's not a very useful shape. We actually want to do this with some sort of do this deliberately, I'm sorry. So let's undo. In order to undo all my mistakes here, I'm just gonna press Control Z a bunch of times. You could also just select it all and hit delete. Now I'm going to select my line tool. I'm gonna start here at the middle, because that's just what I like to do. And I'm gonna make a T shape. I know it's gonna be 1 inch tall. At least because I'm going to be using one of those sticks turned on its side for the middle part of the T. But I want to kind of show you how we change it if we make a mistake. So I'm going to set this to 0.9 inches. In fact, I'm not going to care too much about the lengths of anything right now. I'm just going to make a random shaped T. This is the shape that I want. Oop, forgot that last one. but none of the sizes are correct, right? I need to fix all of these lines because they're the wrong length. So we need to do a few things in order to do that. Now, what I actually want is this beam, or this middle part, to be in the middle of these two. I want these two here to be equal. So what I can actually do is if I go up here where it says constraints, one of these constraints looks like an equal sign. I'm going to select that. And then any two things I click, it will make them an equal length. So I can click this line and this line, for example. They're already equal, so it doesn't really do much. Same thing here, this line and this line should be equal. So it didn't do anything, but these two I also want equal. So I'm going to make this line and this line equal. And if you see what happened, it just stretched that one out so that's the same length as this. So we're getting kind of closer to what we wanted. Now it's symmetric, but our lengths are all wrong. So let's fix our lengths here. In order to change the length of something, we're going to select this tool here called Sketch Dimension. So I'm going to select Sketch Dimension. When that's highlighted, any line that you click on, so I'm going to click on this line, move my mouse over, and I can see that that's 0.3 inches. Now our sticks are actually 0.125 inches thick, or 1/8 of an inch. So when I click again, it'll give me the option to change this value. I want it to be 0.125 because that's how thick our sticks are. So if I do that, it'll now stretch it to be 0.125. It'll shrink it down. And because this one was made to be equal, that one also shrank down. Now this should also be 0.125 inches. This dimension here should be 1 inch. And finally, the top of our beam should be 1 inch as well. Now we've got a fully constrained beam. This and this are the same length, these are the same length, these are the same, and then I set the lengths for all of the pieces. So when your beam turns black, that means it's fully constrained, and you've finished your job of making sure it's got the right dimensions. So I can press Finish Sketch here, and you will see that my beam exists as this beautiful capital T here. Now, it's not much to look at yet. And I just did something that I haven't explained yet. I moved my beam over. I kind of panned it or slid it around. And in order to do that, I'm using a mouse. And I highly recommend you use a mouse when you're using Fusion 360. Using a laptop is certainly possible. I've done it, but it gets really annoying really quickly. So in order to pan around, if you hold in your mouse scroll wheel button and then drag your mouse around, you can move this piece around on your screen. If you scroll with your mouse wheel, you can zoom in or out. There's another useful tool that you can do. If you hold Shift, hold your mouse wheel in, and then move your mouse around, you can actually tilt this and look at it from all sorts of different angles. Since we're working in 3 dimensions, it's going to be useful for us to be able to do this. So I'm going to actually leave it at an angle because it's going to be helpful in a minute. I'm going to slide it over here. Okay. Now, this is our T shape. Actually, if you're doing this on a laptop, I should show you how to do these things. To pan around, you just click this hand here, and then you can click and drag the screen wherever you want, and then click again to deselect the hand. To rotate or to look at different angles, you can select different faces on this cube here, or different edges of this cube. You can look at the corner, for example, or the side, or whatever you want to do. You can rotate this cube using these buttons, or you can just click and drag the cube and kind of tilt it however you want to. So that's one way you can do this. I don't recommend it. It gets really tedious and time consuming. I recommend you just use a mouse, learn the hotkeys I just explained because they'll help you go much faster. Okay, so here's my T. This is the shape of our beam. This is what it's going to look like from the side. And I actually want to take this T now and stretch it out so it becomes a physical beam. We call that process extruding. Now, you can press the extrude button and then make sure your area here is blue selected. And that means that's the area you're going to be extruding. Or you can press E and do the same thing. And I like to use the hotkey, so I use E here. Now, I can click on this arrow and drag it and stretch my beam and make it become a physical object. And then, I want 18 inches, so I would have to zoom out, move this 18 inches. And that's going to be tedious. Or I can just type in 18 here, and it'll make my beam 18 inches for me. And that's the shape that I want. So if I look at it from the side, it still looks like a T. But as soon as I tilt it, you can see that it's actually an 18-inch long beam here. And that's what we're going to be testing. So that's pretty cool. Now we want to test our beam, and we've finished drawing, but we need a point where we're going to load our beam on top and a point where we're going to put our beam on bottom. So if you look at the other ones, for example, I have these little circular pins here that our beam is sitting on, and then there's a circle on top where we applied our load. We're going to add those here. Those aren't actually going to be a part of the beam that we construct. We're just using them as tools for the software. So first of all, we need to find the middle of the top section, or the top face here, and put a circle there. So I'm going to highlight the top so that it's blue. And then if I hit Create Sketch, I'll start sketching on top of my piece. Now I don't like this orientation. I'm going to rotate it because I like this much better. Now I have my beam, and I can find the middle and put a circle there. There's a couple ways you can do this. First of all, we know this is 18 inches, which means we need our circle at 9 inches. This is 10, this would be 9, 8, so this point right here is 9 inches. But let's say we don't know that. Let's find that point using some of the tools we have here. So my favorite way to find the center of a rectangle, if you select a corner and draw a line to the opposite corner and then do the same thing with the remaining corners, those lines will always intersect at the middle of your rectangle. So that point right there is the middle of my rectangle. And then I can put my circle there. So if I select this circle tool, zoom in here to make sure I'm putting it on the actual center there. So if I click and drag, it'll put a circle where I clicked with a radius of whatever I set it to. In this case, I'm going to set it to 0.5 inches. I'll hit enter. And now I've got a circle centered on the beam that's 0.5 inches in radius or diameter. Now, I don't need these lines. These lines were just to help me find the center. So I'm actually going to highlight it, select it, and then press delete to remove it. And I can do that for both lines here. Okay. Now if I hit finish sketch, we're done drawing. I can zoom in on my part, select this area, and I can hit E to extrude it. Now I don't want to add a ton of thickness here because that's going to change the properties of our beam. What I do want to do is just raise it just a little bit so that the force is only here and not on the rest of the beam, but not a lot. So rather than raising it a whole inch, I'm going to raise it 1/100 of an inch, or 0.01 inches. So it's going to be this tiny, tiny little piece of material here. It's not actually going to change the strength of this very much, if at all. But it is going to allow us to apply the force exactly where we want to, right there. Okay, so now I've got our loading point. That's where we're going to apply our force. Now we need our supports, where we're going to put our beam. So if you think about it, this end of the beam is going to be sitting on a table, and this end of the beam is going to be sitting on a table. And when you press in, what do you think is going to happen? Specifically to this end and this end. If we push down right here, then we would expect it to bend, right? This will start to go down. But then what does that mean for these pieces on the side? They're actually going to move up a little bit. So if you kind of think about it, it's flat, and then it makes kind of like almost like a U shape or a parabola shape. And what that means is, even though it's going to be sitting, maybe this last inch or so is going to be sitting on a table, when these ends bend up, it's only going to be touching the table at one point, somewhere in from the end, right at the edge of the table. And that's all we need to model here. So I actually just need to add a tiny point right here and a tiny point right here where it's in contact. It doesn't need to be contacting the whole surface. In order to do that, I'm actually going to select the front face of my beam. So for me, that would be this skinny little section here. If I'm looking at it from the side, this is like the edge here. So I'm going to select that face. And I'm going to create a sketch. And what I want is a little circle here and a little circle here that our beam can sit on. So I'm going to go ahead and zoom in. I want the circle 1 inch from the edge and 1/2 inch down. So I'm actually going to put it right there. So I'm going to put my circle here, 0.5 inches. And I can do the same thing to the edge over here. I think, you know, this was 1 inch. I think this, oh, nope. I think we want it 0.5 inches. I think that's where we want it. Is that right? Does that look right to you? No, we're not far enough over. I can fix that though. So I'm having the issue where this is not 1 inch in from the side. So what I can do is use my dimension tool, and I want the distance from here to there to be 1 inch, not 1/2 inch. And it'll actually move my circle over for me. So if something's ever not behaving the way you want it to, you can always use your dimension or your constraints and constrain it how you would like it. So I drew my pins. I can finish my sketch, and if I look at it from the side here, you can see my pins are here, but they're not doing anything. So I'm going to select one, zoom in so I can select it, zoom in on the other one, hold shift and select this one. Now both are selected. And if I press E, I can extrude both of them. So if I want to extrude it 1 inch, that's actually the wrong direction. They're extruding away from my part. I want to extrude not this way, but backwards. So I can do that by dragging backwards manually, or I can just type in -1 for -1 inch, or go backwards 1 inch. And that will actually extrude it so that it's under my part just like I wanted it to be. Now our beam will be sitting on these 2 pins when we try and bend it. So that's it for designing the beam. Once your beam is designed, if you click where it says design here, you can select all these different options, and we're actually going to go to simulation here. So we're going to start testing our beam. It'll give you a bunch of options. We're going to learn about some of these, specifically shape optimization, a little bit later. But for now, we're going to stick with static stress. Make sure this is selected and hit create study. Now it's going to show you your piece. Without going into too much detail, we want to apply a force downward in the middle, and we want these 2 pieces to be fixed in space, or they won't move. You know, these are our tables that don't move. Our beam is the only thing that should be moving, because our tables are a lot stronger, a lot bigger than our beam. So I need to constrain our table so that it doesn't move. So I can actually select those 2 faces here and constrain them so that they don't move. So they're locked, they're fixed in space, they're not going anywhere. Now I can apply a load to this circle right here. And let's apply a, you know, we can set this to be, you know, 5,000, 1,000,000, whatever we want to be. But for our case, let's just set it to be 1. This is called using a unit load, or just 1, a single load. And as long as we all use the same value, then we can compare our results accurately to determine whose beam is stronger. So if we all stick with using a unit load or a load of 1, then we should be good here. The other way to do this is to keep raising this until your beam fails, but that would take a lot longer. So if we just use a beam of, or a magnitude of 1 here, we can compare across the board. So I'm going to type in 1 and hit enter. Now it's going to press down right there with 1 pound of force and hold these 2 points in place and see what happens. So let's hit solve, and let's actually solve our beam. So I went to solve, let me close that, I went fast. I clicked solve, and then I just went down to solve. Sometimes it will find something that you need to fix or change in order for it to be able to do this, but in our case, we're good. So I'm going to go ahead and hit solve one study. It makes you save it. Save this as whatever you want. I'm not going to rename it. I'm just going to hit save. And you can see the other 2 that I've already done. So when you're using Fusion 360, unfortunately, they will take your model, send it to their servers, run the calculations over there, and then send them back to you. And what that means is it takes a while. Unfortunately, it will not run the calculations on your computer. So you do have to wait. You do have to have an internet connection in order to be able to use this software. But in our case with the school computers, that's not a big deal. Okay, so we're done. Let's hit close. And now we've got a pretty beam to look at. Now let's, right now we're selecting a safety factor, which is not a very interesting thing for us to look at. Let's go ahead and look at displacement. That's going to be the most interesting one because with displacement, we can see how much this beam will bend relative to these other beams. So if you look here, you know, I have this select to, let's go to mil, or millionths of an inch. And let's go here and let's select mil, or millionths of an inch. And let's go here and select mil, or millionths of an inch. And let's look here. Okay, so this one is moving 0.5557 mil. You know, it's moving 1/2 of a millionth of an inch. If we look here, 0.003 mil. So this beam is going to bend a lot less than this one, which means this beam that bent less is stronger than this beam that bent more, right? The more it bends, the weaker it is, therefore the stronger it is. If we look at the one we just did, 0.04 mils. So it bends much more than this one, about 10 times more than this beam, but it about 10 times less than this beam. It's right in the middle of the two. So, you know, it's kind of telling you that this cross section is stronger than this cross section, which is stronger than this cross section. And the reason actually is a little unfair. For this one, it's asymmetric, or if you look, there's material on the left side here that adds strength, but nothing on the right. So you can see this isn't actually a bend that caused it to fail, but it kind of like twisted and collapsed on itself. So this is going to prematurely fail just because it's not symmetric. If this were moved to the middle, this would be a lot stronger. So this is a much better beam design for strength than is a C-channel on its side. But I imagine when you guys are doing your testing, you will find that there are other beams that actually perform much better than this beam or this beam. My lights are flickering. So that's it for this lesson. Now you should have all of the skills that you need to be able to do this yourself. If you have any questions, please don't hesitate to ask Mr. Gillismith or myself. Mr. Gillismith is not familiar necessarily with this particular software, so if it's a software-related question, it would be better to ask me, Mr. Hernandez, but he can certainly help you understand the concepts and kind of get in the right direction. So with that, you should have all of the tools you need. Good luck. I'll see you guys in the next one of these videos.